Hello everyone. So through this video tutorial we are going to explain about how MOLDEX 3D help our customers, especially when they need some assistance to optimize the cycle time and defect free component. So in our case this is the part model for cavity system, and the runner is a cold runner system. This is the runner cooling channel layout, and if this is the sectional view of the component, you can see this profile. Further, wall thickness of the product seems to be minimum as 0.5 millimeter, maximum as 1.1 millimeter. And quite important thing is, throughout the component the wall thickness distribution is not consistent. Instead, we could see the variable wall thickness. Of course, while we have variable wall thickness, there are great possibility for some molding defect, but still let me handle them with the mold test simulation. And this is the sectional view of the runner design, especially in this location. You can see circular runner with the pinpoint gate, and here kind of a semicircular runner. This is what customer wants to use for this particular product. And cooling channel is a very simple design. Cavity side we have 4 cooling channel, and core side we have 2 cooling channel. And this is the cross sectional view of the mesh elements in MOLDEX 3D. For all of our simulation we are using two 3D meshing technology, especially BLM, bi-layer meshing. Here you can see the combination of prism and the tetra elements. So this will help us to predict the shear and the shear thinning effect in precise way. Further, material, customer has given the material data. With the MOLDEX 3D material hub cloud, we have find out what could be the nearest material or the equivalent material. As per the suggestion from material hub cloud, we decided to go with the polypropylene BH374MO equivalent material for this simulation. Then about the process condition, usually when the mesh model is ready, the solver, MOLDEX 3D solver automatically suggests the process condition like this. You can see here, filling time, the software recommend to use 0.5 seconds, packing time 3 seconds, cooling time 6 seconds, mold open and mold closing and ejection all together 5 seconds, and cycle time 14.5 seconds. Further, melt temperature suggests to use 240 degrees Celsius and mold temperature 40 degrees Celsius. This is the default scenario which is given by the MOLDEX 3D solver. Further, we want to do multiple iteration. That's the reason we decided to change the cooling time from 6 seconds to 10, 15, 20. So let me check the results in the upcoming slides. First one, we want to confirm while changing the process condition with respect to the given design and material, any possibilities of the shortcut. No, while we study all 4 results, the cavity get filled without any shortcut. If need further confirmation regarding this particular subject, still we can refer this animation. From this animation we can understand how the material will fill the cavity, possibilities of the shortcut, possibilities of the imbalance. But even from this animation we can one more time we can confirm that there is no shortcut. Then pressure requirement. Usually while we are changing the process condition, there is a possibility for the changes in the pressure. But in our case, while we study all 4 iteration, the pressure requirements around 48 megapascal to 49 megapascal. Just 2 megapascal difference, not more than that. So we can use any cooling time in terms of pressure. Then we would like to study the weld line. Of course, in this particular product, we have a small pocket, especially in this location. While we are having this kind of pocket, the weld line is unavoidable. Of course, the MOLDEX 3D solver also highlighting the same. Over this particular location, we may have the weld line. Further, we would like to study possibilities of the material degradation with respect to different process condition. Here, the melt temperature during the molding cycle seems to be 229 as minimum, 241 as the maximum. Still, for the selected polypropylene material, it is fine. So that's the reason there is no possibility for the material degradation. This is also we can evaluate. Then we would like to check how much quantity of shear might be induced during the molding cycle with respect to the design and the process. In our case, the predicted shear rate seems to be 5.1 e power 5. For the selected polypropylene material, it's slightly higher. Of course, in our case, due to the gate design, the material experiencing slightly high shear. If it is required, of course we can The customer can rework on the gate design, then it may help us to reduce the shear effect further as possible. Then sink mark, we know very well while the part having any uneven wall thickness distribution, thicker region, there is a possibility for the sink mark. In our case, the gate location, it having the thicker region. In this location, we may have the sink mark with more than 0.1 millimeter depth. And moreover, this location, the collar location, this location also slightly thicker. In this location also we can expect a sink mark. Then we would like to study the volumetric shrinkage, because again the volumetric shrinkage might happen due to uneven wall thickness, cooling efficiency, and process condition. In our case, of course, the gate location going to experience slightly higher volumetric shrinkage. That's the reason, of course, we are getting the sink mark over this particular area. Such a cross interpretation also we can perform with the Moldex 3D. Then we would like to check how much quantity of clamp force might be required. While studying all four results, the tonnage requirement seems to be 81 tons to 82 tons. Now the customer can take this data. Accordingly, they have to select the suitable molding machine to avoid any challenges during the real molding. Then we would like to confirm whatever the packing time which we have given, they are enough or not enough. How we can conclude such information. Now we can take the activity or the activeness of the gate. In this particular project, we have given 3 seconds as the packing time. At the end of 3-second packing time, the gate area already solidified. It means what? The given 3-second packing time is good enough for this particular component. Further, we would like to study what will be the part weight, because after the design, from the CAD model, if we try to understand the part weight, we may get some numbers. But during the real molding, due to compressibility of the plastic material and the packing effect, we can expect slightly higher part weight. So in Moldex 3D, the solver will consider your design, material compressibility, and process condition. Then it shows 7.2 grams will be the part weight. Finally, we would like to check how much quantity of shrinkage and warpage may happen in the particular component with respect to different cooling time. In this case, for the shorter cooling, it means 6-second cooling shows 0.8 millimeter as a shrink and warp, whereas longer cooling, 20 seconds cooling shows 0.74 millimeter as a shrink and warp. So now based on the customer requirement, if they want to achieve very minimum shrinkage warpage minimum shrinkage warpage, then they have to go with a higher cooling time. Instead, if they are focusing about cycle time, still they are fine with the 0.8 millimeter shrinkage warpage, still they can go with the 6 seconds cooling time. Then we want to check any impact over the linear shrinkage with respect to cooling time. So here what we have observed, the longer cooling time shows 1.48% as the linear shrinkage, whereas the shorter cooling shows 1.58%. A small difference, like a 0.1% difference with respect to the different cooling. And this is the summary. So even with the different cooling time, the part will get filled easily without any short. That is the first conclusion. Second one, even if we are changing the cooling time, the pressure requirement around 48 megapascal to 49 megapascal, not more than that. And moreover, since the part having a small pocket, the weld line is not unavoidable. That is also logical. Moreover, while we are studying uh, wall thickness of the particular component, what we have observed, this particular part having uneven wall thickness, some of the area having 0.66 millimeter as the wall thickness, other area having 0.96 millimeter as the wall thickness. Then shear heating, during the molding cycle, the minimum temperature of the plastic material 229 degrees Celsius, maximum is 241 degrees Celsius. So within this window, the polymer won't get degraded. Further, while we are studying the shear rate, we have predicted 5.1 e power 5 as the predicted shear rate. Of course, this is slightly higher for the polypropylene material. It happened due to the gate design. If required, customer has to rework on the gate design. And while checking the sink mark possibility, of course, the gate location may experience the sink mark, may slightly higher, like the sink mark depth may be around zero point zero 0.01 millimeter. Further, while we are studying the linear shrinkage, the shorter cooling 6 seconds cooling source 1.58 percentage and the longer cooling source 1.48 percentage. With respect to the requirement, customer can decide whether they would like to go with the 6 seconds cooling or 20 seconds cooling. Regarding the clamping force, for all the scenario, the average clamp force seems to be 81 tons to 82 tons. So accordingly, customer has to select the molding machine to avoid the challenges during the molding cycle. While checking the shrinkage and warpage, the shorter cooling 6 seconds cooling shows zero point 0.8 millimeter as the displacement, whereas the longer cooling, lengthier cooling 20 seconds, it shows 0.74 millimeter as a displacement. And part weight, for all the scenario, the part weight seems to be 7.25 grams. So I believe this case study and its explanation may give the deep insights about how the MOLDEX 3D works and what kind of optimization, quality related protection and machine selection criteria, possibilities of the material degradation which we can handle effectively with the MOLDEX 3D software. Thank you.